Alan Downing, ladies and gentlemen, for the ArmBot Challenge. Now, everybody brought an arm, right?
I thought that was a table bot.
All right, all right. Yes, yes. Now, how about robot arms? No, no robot arms. We got one. We got one. Come on up. Okay, everybody needs to build a mobile manipulator. My definition of an arm for this competition is like a gripper or something that moves, grabs something, or anything. So if you've got a gripper, I count that as an arm in this competition. Okay. So if anybody got a gripper that they want to show off? Okay. Anyway, so please, you always get the question, what does your robot do? Okay. All right. We now have robots that can go around the floor and vacuum sometimes if they're turned on. But now you need to have it manipulate and do something with it. Add an arm to your robot. Okay. So you ready? Yes.
Hi, I'm Charles. I was looking into educational robotic arm, and I was looking for one that's fairly inexpensive, about $200 to $300, and it comes with a graphical programming environment that I can use as an educational tool for my kids. So I found one recently on Amazon. It's called X-Arm. So I'm going to show you here that I put it together. You can do the level 1 and level 2 challenge. So let me just show you.
Level 3 is anything you define. So.
Okay, level 1 and level 2.
Okay, but just make up something.
Right, right. So it has ultrasound sensor in the front. So once it detect that, it will just run the pre-programmed routine, trying to pick it up, and then put it onto another location. Yeah, so going forward, for the level 3, I plan to add a camera and then try to use the camera to guide the arm to find the object and then to place it.
It plays chess.
Oh yeah, something like that. But for some reason, the ultrasound can only detect large objects. Okay, hopefully, I will have something more interesting to show.
Thank you very much. Hey, this is the best I've ever seen. We got 3 arms. This is by far the best arm challenge. So Marco, you ready?
Not quite yet. So I actually reactivated a rather old arm I built, or we built for a Science Olympiad event at 2016, early 2016. And I got it kind of working on kinetic again, but it still has its issues, so let's see how it goes. There's basically the complete ARVIS simulation in real time.
Looks like it's been flying. Right? With the rubber band.
No, the rubber bands actually hold some batteries as ballast in the back there. So, yeah, those are little dynamic servos, and they are pushed over their limits. That's why it's basically shaking like crazy. That's pretty much what it's doing right now.
Okay, so a few years ago, Google, you might remember, had like 14 arms all working together, reproducing 800,000 grabs of objects and replacing them and using it for deep learning. And I said I wanted to do that. But I wasn't the only one to say I wanted to do that. The folks from Berkeley, who actually helped out on that, wanted to do it too. And last year, I saw them give a little presentation about a standard that they were defining called RepLab. So I said, I want to have one, and this is the RepLab. It's got a whole paper here on how to do it yourself, and its idea is to learn deep learning, reinforcement learning, things like that. It comes with a whole bunch of software. It's meant to that these things can be stacked up on top of each other, so you can have, Berkeley has a whole, can have like 8 of them all running in parallel.
Phase one, your robot waves.
And let's see, just making sure something's right. Okay, and and to have these things all running in parallel, they come with a Docker image. They have a Docker image that you can use that just load up on all the different arms, and you can start things up running. I want to do development on my own, so I am running mine. I upgraded to Melodic. I did a whole bunch of little changes here and there to get it. This is running right now. This isn't running deep learning. They have a couple pre-trained models on theirs. But mine is just running something called, it's the best demo that they have, which just keeps on running and running. Proximable access, they call it. And it's just, it has a SR300 here. It's looking down at the tape, at what's in there. Oh, it's going to grab something. Ooh! There you go. And it does some 3D imaging, clusters it all together, picks what it wants. It uses move it to get the arm down to it. It uses the proximal axis to figure out what orientation of the gripper it is and where it wants to close it. You can figure out if it's soft or hard objects. And you can train several other things. There's that are for deep learning. And they also have one for reinforcement learning, which is to do reaching. There's some demos on how that works. It basically finds you define a point, and it uses the OpenAI GIM infrastructure to figure out how to move. It starts off random and eventually figures out how to move exactly to that spot. It kind of learns the physics of the arm that way. And I'm beginning to program my own stuff, which is based on PPO, which is the OpenAI reinforcement learning stuff, and yeah. So let's see.
Alan,
Yes, sir.
we have one more on bot.
Excellent.
So I'm looking at the phases, and phase one is build a robot arm that moves or waves. And Dee Dee here has a waving robot.
That is a waving robot. Thank you. So anyway, if you want to learn how to build this, come on over, chat with me, and I'll do it. That looks like awesome.
Talk while I plug it in.
I will talk as long as you want. I will bore these guys to death.
Well, keep them alive.
So actually, this thing is out of the box. It's not being tuned or anything. It's actually not using any AI for this particular demo. In their paper, they could pick up about 23% of the time, but after doing training for a couple days, it can pick up about 16% of the time. I haven't done that training yet on this particular arm. I see it plugged in. All ready?
Oh, I'm just going to run my little program and then I'll be done.
Okay.
Or I can talk and...
You do whatever you want.
Okay, sure.
You have 5 minutes.
That's,
I'll give you 1 more minute.
okay, this thing will keep on running. There's a whole bunch of modes. You can collect data for days if you want. And it stores the before images, the after images, things like that. So I really, if you want to learn about deep reinforcement learning, yes sir.
Where's the camera?
The camera is right there. So the SR300.
Okay.
This is a Widow X from Robotics. It's one of their cheaper arms that is capable of doing this type of thing. They were able to run their many thousands worth of runs without having to replace any of their servos. The biggest one on this is the AX64s.
Is that a depth camera?
Yeah, it's a depth camera. It's one of those Intel depth camera that gets obsoleted every 6 months after
Oh,
they
yeah.
And I can tell you, I had to do a kernel mod to get that work on my robot. Okay, here we go. Thank you very much. Say your name.
Okay,
Robot.
sure. My name is Domotics, and this is a welcome bot. So its job is to welcome. So I made, the concept came about 2 ways. I went to Japan, and while I was at the Maker Fair there, I saw this cute little cartoon robot with its hands above its head. It's a Japanese character, and so they have it in the windows, and you see like kids walk by, and it draws people to the stores. And I thought, that's cute. But then someone said, you know, it'd be cool if a robot had a sweater on it. I kind of like the concept of a robot with kind of fuzzy, cuddly, welcoming, instead of so hard and stiff. So what I have here, I drew it up. Took me a couple iterations. The first one looked like a snowman, so I changed the head so it doesn't look like a snowman. And I know it looks like a teacup. My kids have already told me, that's fine. But it has a raspberry, so I designed it in Fusion 360 and printed it out on a LUTspot TAS. It has a Raspberry Pi in the middle. Yeah, I had to sleep on the couch a couple times for some of these big pieces because my printers are in my bedroom. So there's a Raspberry Pi with a touch screen here and a camera here. So if it sees a person, then the person will show up in the screen. I guess I could kind of demonstrate if it's going to see me. Or, oh, there we go. Oh, yeah. It welcomes me. And so, and then, you know, the eyes are cute. There's a couple smaller ones I have. I took to Maker Fair, but are now in my office, so they also welcome people without the Raspberry Pi thing. And yeah, I have these ultrasonics and the lights, but then I ran out of time, so this is where I'm at. Well, I was invited, so.
Yeah. See, but you know, she didn't make it specifically for this. You've got arms on some of your robots here. Any more arm bots?
What?
An ARM processor.
Yeah.
I think your daughter qualifies. I think they should come up here.
Oh, the in move?
But
Yeah.
So you want to do the in move now?
Or do you want to do it with your brother? Your choice.
but it's my daughter, so I have to ask her.
Question.
Yes.
How many printers did you print that on, and how long did you print it?
So it's nice that I have a LUTspot TAS because, yeah, the LUTspot Mini would have taken, though, I mean, it's kind of impressive because my daughter's in move right over there. We only had one LUTspot Mini, and she printed that within a month. So, but this one, I think it took about 2 weeks, maybe, or 10 days. I wrote on the list like 10 days because I'm in a hurry to make it before the Maker Fair. So yeah.
It's really impressive.
Oh, thank you. Thank you.
I think that's it for the ARM bots.